Hi everybody, welcome back. This is the last section of Chapter 11, 11.4 Geometric Series. Following this section, we will be taking a quiz. Today we're going to take a look at the main ideas of finding sums of a geometric series and finding specific terms of a geometric series as well. One new vocab word, which is the geometric series. Again, we've already talked about a few sequences of series when we did the arithmetic. Same idea, but with geometric. So a sequence is a set of terms, whereas a series is those terms added together. That's the idea that we're going to look at here today. So to start things off, let's look at another real-world example. So suppose we email a joke to 3 friends on Monday. Each of those friends send the jokes to 3 of their friends on Tuesday. Each person who receives the joke on Tuesday then sends it to 3 more people on Wednesday, so on and so forth. So here's the scenario. You're person number 1, you send it to 3 friends. And these are these awful chain letter emails that you get that say forward it on to 3 other people. Otherwise, you will have bad luck. So they continue to forward on. They send it on to 3 of their friends each day. And the next day, their friends check the email, they see the email, and they figure, oh, I don't want bad luck, let's send it on to 3 more people. And pretty soon, come Wednesday, all of these people have heard the joke. So if you can imagine, the geometric sequence spreads rather quickly. Now, the geometric series is the idea of taking the number of people who actually know the joke and then adding them together. So for instance, day 1 there's 1 person who knows the joke, day 2 there's 3 people, day 3 there's 9 people, and day 4 there would be 27 people. So to figure out the total number of people who know the joke, I would simply add those numbers together. Once again, the numbers itself, 1, 3, 9, 27, 81, 243, 729, so on and so forth, they form the geometric sequence. As soon as I add these numbers together, this is what we call the geometric series, and this is what we're going to work with today. Now remember, the big difference between the geometric and the arithmetic sequences in the series, the arithmetic starts at first term a sub 1 and has a common difference, which is then added or subtracted to receive the next term. The geometric series starts off as a1 and it has a common ratio, which is multiplied or divided to get the next term. So for in this scenario, a1 would be 1, my common ratio would be 3. So multiplying by 3 is what gives me that next term. The difference between a sequence and a series, the sequence is just the list of numbers, whereas in the series is those numbers added together. So for instance, if I want to know how many people added, or how many people had their joke by day, let's see, 1, 2, 3, 4, 5, 6, 7, 8. By day 8, I simply add these up, and that means 3,280 different people have already heard this joke by 8 days. So the question is, how can I do this quicker? We like the idea of being able to add all these numbers up, but it's time consuming to sit there and add together 8 single numbers after you have to figure out what each of those 8 numbers are. So we want the shortcut. Here's your shortcut for finding the sum of a geometric series. So the sum S sub n of the first n terms of a geometric series is given by the following equation. Now, I've found after teaching this for a few years that this is usually the equation that students are going to remember. The sum of the first n terms is equal to a sub 1, the first term, times the quantity of 1 minus r to the n, where r is your common ratio, n is the number of terms you're dividing, or number of terms you're adding, divided by 1 minus r, where again r is your common ratio. Now this is a geometric series, and since it is a geometric series, r will not equal 1, because if r is 1, that means this number is not changing, because if you start off at 2, 2 times 1 is 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 2, and if I make r equal to 1, now I run into this issue of division by 0, hence the reason for r not equaling to 1. Alright, so let's give this a try. Contagious diseases can spread very quickly. Suppose 5 people are ill during the first week of an epidemic, and each person who is ill spreads the disease to 4 people by the end of the next week. How many people have been affected by the illness by the end of the 6th week of the epidemic? So we know what we're doing. We know what we're trying to find. Let's see if we can spice this up a little bit. How about we look for disease, no, sickness, no, healthy. Alright, let's see what we have here. Not much to work with. I'm just trying to spice it up a little bit. Looks like I can get an elephant taking a pill trying to fight off this epidemic, so we'll put that on there. I want to know how many people have been affected by the illness at the end of the 6th week. So what we're doing is we're trying to find the sum of people. So we're going to use our sum formula for a geometric series. Which is given by that formula right there. Now, based off the problem, I can see that there are 5 people ill during the first week. That means 5 has to be a sub 1. So we're going to fill that in. Each of these 5 people then spreads the disease to 4 people. So your common ratio has to be 4. Finally, I want to know how many people are ill by the end of the 6th week, which means I'm looking for n equal to 6. Now, make sure we're watching our calculator notation, what needs to be done first, second, so on and so forth. So if I pull up my calculator here, when we complete this, the first thing we have to do is this parentheses, which means I need to do the 1 minus 4 to the 6th first. So I'm going to type in 1 minus 4 to the 6th power. Now your calculator can handle this, but just make sure you're doing 4 to the 6th first and then 1 minus that. So don't go 1 minus 4, press enter, get -3, and then raise that to the 6th power. 4 to the 6th has to be done first and then the 1 minus. So there's our 1 minus 4 to the 6th. Now I'm going to take that number and I'm then going to multiply by 5. So we'll times that by 5 to get this number here. This is the numerator of the expression. Now I then want to divide that by 1 minus 4, or a -3. If I divide by -3, that gives me out an answer of 6,825. And that, my friends, is the number of people that are affected by this illness after 6 weeks. So it looks like that elephant has a good idea by taking that medicine. Stay away from that illness. 6 weeks' time is almost 7,000 people sick. And that's a geometric series. Okay, so let's try another one. I've introduced this notation before back when we did arithmetic sequences. This is sigma. It stands for summation. It stands for the sum. So, from this given information, if you can remember, this is a times r to the n minus 1. So, just from this one equation, I have everything that I need in order to evaluate my problem. So, first thing, I'm looking for s sub n, and since I'm going from 1 to 12, 12 is the number of terms that I'm trying to add. A1 is the first term, which is given right there, so 3. 1 minus r, remember this is your r, 2, to the nth power, which is 12, over 1 minus r. The rest, calculator work. So, let's try it. 1 minus 2 to the 12th power gives me this. We'll times that answer by 3. So that is the numerator. and I want to divide that by 1 minus 2, or a negative 1. So the sum of 3 times 2 to the n minus 1 from 1 to 12 is equal to a value of 12,285. Alright, let's try another one here. Find a sub 1 in a geometric series for which s sub 8 is 765 and r equals 2. So things changed a little bit with this one. This time we are looking for a sub 1. So a sub 1 is my variable. 1 minus r, which they tell me is 2, to the nth power. Since they give me a s sub 8, that makes 8 equal to n, and it's over 1 minus r. Over here is s sub 8, or 765. And now it's just a matter of attempting to solve. Wrong thing. Let's see if I can grab this. It's just a matter of attempting to solve for a sub 1. So let's do some simple math here. We have 765 equal to a sub 1. Now we're going to have to do some calculations here, so let me pull up my calculator. We're going to go 1 minus 2 to the 8th. Negative 255. So I have a negative 255 over a negative 1, which means 765 is equal to, negative over negative is a positive, 255 a sub 1. Now, I'm looking for a sub 1, so we'll solve by simply dividing 765 by 255. 765 divided by 255 gives me an answer of 3. So, if my common ratio is 2, I add together the first 8 terms and I get a total of 765. That means the first term must be 3. As always, we have a few example problems here for you to try. I have 4 examples. First 2, we're looking for the geometric sum, or the geometric series, s sub n, given this information. Again, answers are over here on the right. Second one, we're looking for an indicated term, so we're trying to find a sub 1, given this information. And fourth one will be a word problem. So give those problems a try tonight. Tomorrow we'll take a look at some more of this in class. We'll answer any of your questions. And enjoy your night. We'll see you tomorrow.